Hi and welcome everyone. In this tutorial I will show how to model the screws using Abaqus software. The screws used to link between cold formed steel built up section. To do this I will take this example as you see here, this article, compression tests of cold formed steel eye-shaped beam sections with edge and web stiffeners. This is an experimental study conducted on compressed elements. As you can see here, this is the section used in this study. The location of the screws in the cross section is as you can see. In the upper part of the web we have the first screws line, and downward in the down part of the web we have the second line of screws. In the longitudinal profile we have the column, our column, and this is the location and the longitudinal spacing or interconnection between our screws. The distance or the height of the column of our column is 300 millimeter. The spacing, or we used 6 screws, 3 in the upper part of the web and 3 in the down part of our web. This is of course the end plates. Distances of screws are 50 millimeter between the first screw and the edges, and 100 millimeter in the middle or between the screws. First I will open Abaqus. I will go to the parts. I will select shell because cold formed steel are shell members. I will let this deformable and 3D. Our problem is 3D modeling. The approximate size of our sketch, we will let it to 200. You can change that to your liking. If you see that 100 or 300 or more is fitted to your problematic or your sketch, and you will click on continue. First of all, we have to sketch our section. As you can see here, we have the distances which are in table. In my case I have already sketched the section, and here I will extract it. Click on done. This is our section, and the screws, as you can see, will be located here. I click on done. We close it. I will repeat the operation. Sorry, I must select extrusion, shell extrusion. Yes. I will redo the operation. Done. And yes, it tells me to put the depth of my member or my column. So the depth or the height of our column is 300 millimeter, as here. I will put 300 and OK. So this is the column extruded when extruding the section. The second thing we must do, we have to put the properties, the mechanical properties. We go to this section, we select here, we go on mechanical, elasticity, elastic, Young's modulus, For example, let's take this value and Poisson ratio 0.3. The plasticity. In this part, you can use this. You can put the information of your stress strain curve, or you can use the elastic, perfectly plastic model, which fits in case of cold formed steel and can replace the true stress strain curve. So I will put only one value, which is the ultimate stress or the elastic stress, 600 megapascal, and the plastic strain at this point, at the first point, must be 0. I click on OK. Afterward, I will give a thickness to my shell. We go on shell, homogeneous. For example, let's put a value of 1. Okay. Afterward, I will introduce this thickness to my whole member. We click here, we select the column, and we click on done. This is the definition method. We will use the middle surface and let all this parameter like that. Okay. So the color must change. That means the thickness is correctly introduced to your member. I click on done. Afterward, I go to assembly. I have one part which is only the column, so I click on OK. Then I will go to the interaction module. In this module, we will not create, as you see before, we are not modeling the physical parts of the screws. We are simulating the screws in our model. So to do that, we have to go to this option, which called create attachment points. I will rotate my model to locate it correctly. This is the upper part of our web where the screws are located. So I go to this edge here, click on this edge, yes, done. It gives me an arrow here and the beginning point. I click on yes. It shows this window. This window is considering of the distances between our screws, the location of our screws in the direction of y and the direction of x. For the x direction, or for the y direction first, we have these specified points along edges. I will let it by number, and number of points I will let it 1 because I have one screw in this direction. The offset from start point, here I have to know which is where to find the distance. So first of all, I will go here to my sketch again and calculate this distance. This distance is about 2094 millimeter. So I will divide it by 2 because the screws will be located in the middle of this distance. I will get about, let's put it 10.5. I go again to the interaction module. I will redo the operation of generating attachment points. So the number of points, as I said before, is 1. The offset from start point, which in the y direction, I put it, as I said already, 10.5. I finished with this parameter, or this distance, the y direction. I will go to the x direction, or to the, in my case, to the z direction, which contains the distances between my screws. To do this, I have to open my example. The distances are 50, 100, 150. Okay, so I have to know the number of rows. In my case, I have to put 3 rows, as you can see here. So I put 3. The spacing between rows. The spacing is 100 millimeter, as I have here. So I put 100 millimeter. The offset from edges, I mean this offset from edge distance here, is 50 millimeter. I put 50 millimeter. Afterward, I will go to this parameter, adjacent faces, and I will select my face where the screws will be located. I click here and I click there. Okay. So as you can see, the upper part or the upper line of screws in the web are already modeled. This is only attachment points that we will do, that we will take to introduce my mechanical properties of screws after I finish modeling the down part of screws. In the down part, we will do the same operation for the attachment points. I will go to this edge this time, to the down edge. Yes, I will put 10.5 here, and the same distances will be reintroduced. 3 rows. The spacing is 100 and the offset is of course 50. This time I will select this face and click on OK. So here I finished introducing my attachment points. That's it. In the second part, I have to define the section for my attachment points and attribute their mechanical properties, let's say. So I go to this, create connector section. Here Abaqus provides many methods to do the mechanical properties of our screws or our section. I will let it to the first assembled complex. The assembled complex, we will let it for beam, and you click on continue. It gives this. I have the window too large, so I have to adjust my window. Display setting. The resolution, I will go on this. Click on OK. I will revert to the original resolution because I don't need it anymore. So here I created a section for my connectors or my screws. Afterward, I will go to this and attribute this section into those attachment points. I click on here, point based. In this part, Abaqus tells me to select attachment points for positioning my fasteners. So I will go here to this option of selection, click on attachment points. I will go to the cross-sectional view here, and I will select all the attachment points. So as you can see here, all of them are selected in red. I click on done. Okay. So here it tells me between in this part here the target surfaces. So I must firstly define my surfaces here and introduce them there by selecting fastened specified surfaces by proximity. So first of all, let's stop this operation and firstly define surfaces, and then we will resume our connector attributing. So I go to surface. Here I will call it upper web or up right web. Let's call it like that. It is this part. Okay, and done. Or let's select the right part of surfaces together. We call it surface 1 or right surface. Right surface. You can call it the way you want. Select the two right surfaces here in red. Click on done and click on brown. And the left for the second surface, the left surfaces. Left surfaces. I will rotate my model and select the left surfaces. Click on done. Let's give it purple. I will go to the creation of fasteners or attribution of fasteners to my attachment points here. Click on point based. I will reselect my attachment points. Click on done. I will let it to the default, the direction vector. I will go to the approach of target surfaces, click fastened specified surface by proximity, and click on here to select the first surface. Abaqus tells me to select surface from my view. I can do this, of course. As I already defined my surfaces, I need only to go there, surfaces, click the right surface, and add another row which contains the left surfaces. Okay. The criteria. This is it for the domain. For the criteria, we will let it face to face method like that. Property. Here you have to give a physical radius to your screw or the diameter of your screw. Let's see. In my case, I will put 4.8, diameter of 4.8. The connector sections will let it like that, and the formulation, the adjustment. Okay, you are okay, then you click, you confirm. Yeah. Here, as you can see, the attachment points become squared. That means my screws or my sections or my connectors are well attributed to my attachment points. Here you can continue your operation using introducing the boundary conditions, the forces, and the screws will be, you will see the deformed shape, and the connection between your surface is very accurate. You have only to know one thing, that this method is only used when there is no damage happening in your screws before reaching the ultimate stress. If the damage of in your screws happens before that, you can't use this method. Thank you for watching this tutorial, and goodbye.